Maybe I can copy and paste it.
So it's the
Chapter 17. I'm trying to find the formula too. Sorry, margin of error.
yeah. See, I couldn't find it either, and that's where I was.
It's in section 2.2.
2.2.
Yeah. So it's
So
that
this is
P.
the formula for the confidence interval of upper and lower bound, is what you're saying?
Yeah, provides the margin of error in upper and lower bounds.
Okay, so correct me if I'm wrong, Josh. Is this the p minus z square root of p 1 minus p over n?
That's your lower bound.
All right, that's what I figured.
Yeah, your upper bound would be your plus.
Yeah, it'd be the plus.
Yeah, so I guess it's just the difference between the two, right?
Yeah. Yeah, I mean, it's the difference between the 2 divided by 2, because...
Yeah, you'd have to add them and then divide it by 2, and that would be your...
So in this case, it's 0.75 times 1 minus 0.75. 0.75 times 0.25 divided by the n, which was 65. Get a number. You find the square root of that, and then you times that by the confidence interval 95%, which is 0.196. So 0.75 times 0.25 divided by, I believe, n was 65. You get a number. You find the square root of that, and you times that by 1.96.
Okay, so you end up timesing it. You put the 95% back into it then.
Oh, oops. Yeah, the n is 60, not 65.
65, yeah.
It's 60, yeah. Did you get it?
Yeah, just a sec. I'm trying to figure it out real quick. All right. And that's the margin of error, okay. Okay, and then the lower and upper bound, all you got to do is add and minus the 0.75 to that.
Yeah, or just use your spreadsheet.
Yeah. Okay. Perfect. All right, so number 10, that's as far as I got. Let me read it real quick. Actually, we already do the lower and upper bounds?
Yeah.
Lower bound 0.640, upper bound 0.860.
Yeah, so if you change the 60 to an 80, you go from a lower interval of 0.64 to 0.454.
Decrease.
This would be 10, right, on 11?
Um,
20.
20? Okay, yeah, I didn't know which number to use. I didn't know if it was the top number or the bottom number. But I guess it's supposed to be the end, right? That's how many people you would need, or whatever.
so you just do the...
Yeah, okay. My bad.
Yeah, you do the 20 times 0.5, right? And then that gives you 10, and you got to get greater than or equal to 10, right?
Yeah. I did it like he showed on the video. and it's basically you go until both requirements are over 10.
Gotcha.
So I'm like, but that one's kind of easy because it's only in a half, so it's going to be, that it was going to be at least 10 and 20.
So on this one, try and work it out backwards. Minus. So the equation would be n times the 1 minus 0.1. And then Josh, or Dennis or whoever, how do you do, if you do the 1 minus the 0.1, which is p, and then you still got to find out n, you take 10 divided by 0.9 to find out n?
This is for number 12.
Yeah, number 12.
So I think you just even make it a bit more simpler than that. You just times it by whatever the p is. So p is 1/10, you times it by 10. 10 times 10. If it's 1/2, you times the 10 by 2. If it's a fifth, if you times it by 5. So it's 100.
So 100, okay.
Yeah. So whenever. Yeah.
So another way of figuring it out was you take 10 times the p, so you get 1, or so you get 1, and then to get that number up to 10, you just
Yeah.
by 10. So 10 times 10 would be 100.
Oh, okay, I see. Yeah, it makes sense on the thing too. Oh, I get it. All right. Really, with that? Okay. Because then I guess your lower goes to 10. Okay. Because that's the lowest. That's your smallest would be the 10 that it could be.
Yeah.
And you had to make it pass. You have to have both of them over the 10.
Yeah.
Both of them have to be greater than 10. So that would be the lowest you could go would be 100. Yeah. Okay. I get it now.
I actually think the formula just confuses it. You just times it by whatever fraction it is.
Yeah. Yeah. Exactly. Well, I'm not even looking at the formula. I'm looking at the spreadsheet. Just going up from there.
Or I guess a super easy way that I did is you just do 10, which is what we're trying to get at least 2, right? So 10 divided by the p. So 10 divided by 0.1, and that's how I got 100. That was this really easy way.
Yeah.
Oh, yeah, I actually guessed on 13, but I got it right. But why is it true for 13?
13?
So 13 is the same thing as
Because it's 1 4.
Above 10 or above.
Yeah.
So to get the first one, you do 38 divided by
80.
80 to get the p.
So, which is 0.022.
Oh, I got 0.475.
Oh, that's a p value. I'm sorry. Yeah, your p hat is 0.475.
Yeah, and then you take the 0.475 times n, which is 80, and that's 38. So that's above 10. So that one's satisfied.
They're both
Now
above
you do
10, so it'd be true.
Now you do the other one, which is the formula n parenthesis 1 minus the p. So 1 minus 0.475. That gives you 0.525. And you multiply that by n, which is 80. So that answer is 42. And with 42 being above 10, that one's satisfied as well. Does that make sense?
Yeah. Yeah.
Okay.
Dude, you're awesome. I just typed it into the spreadsheet, so it was easier.
Head on.
Sorry.
So for the P, that one, what, 38?
0.475.
30.475. The test statistic, what does it say on the spreadsheet?
Z is negative 282. No, or 2.282.
Number 16, the p-value for that one.
0.022.
And then
Actually, I think you might have added the two wings.
What's that?
For that, I think you might have accidentally included the two wings. It's just the right portion or the left. It's half of that.
Oh, you're right.
oh yeah, everything to the left.
Yeah, it's 0.011.
What was that?
It's 0.011. It's just half it.
0.11. Yeah. Okay. Good catch.
The T statistic still the same then?
Should be.
right? Okay. So with that being less, or wait, that'd be less than. So we reject the null for number 17. And
Guess so.
And then 18 would be D, I think. Put 18 for, or D for 18, Josh. Yeah.
Sweet. See what happens.
Perfect. 100%.
Nice. It's not bad for doing my homework.